Okay, guys, it's day 3 of Unit 3, I guess, Chapter 2. We're looking at simplifying rational expressions. So just a little bit review. All we're looking at are fractions. We're trying to simplify fractions. So if I had the fraction 6 over 12, what you would do is you could look at this and say, how many times what common factor do 6 and 12 share? And the answer would be 6 is the biggest one. And it goes into 6 once, and it goes into 12 twice. And then we would say that 6 over 12 is 1/2. Okay, you guys know that. And then here, if the constants, the coefficients or the constants don't cancel out, maybe the variables will. So if I have x squared on top and x here on the bottom, you can get rid of 1x on the bottom and get rid of 1x here, and you're left with 3x over 5. And that is the gist of what we're going to do today. And let me just scroll. So this is the note here. I'm going to jump around a bit if it'll let me. Will it let me? Let's find out if it'll let me. It won't let me. What's going on here? Let's see. Ta-da, fixed it. Okay, so what you do here is you have 12 and 15, and 3 goes into 12 4 times. 3 goes into 15 5 times. I have an x squared on top, so that's x times x, really. And on the bottom, I just have x, so I can divide these out. And they don't disappear, they just are equal to 1. So if I said x over x, that's equal to 1. So that's just times 1, and then they kind of disappear, but they cancel their way out. So this becomes 4/5 x, or 4x over 5. You keep looking here. Don't get rid of negatives, so the negative stays here. 6 once, 6 4 times, 2 m's on top, 1 on the bottom, so that leaves me 1 on top, nothing on the bottom. 5 n's on the bottom, 3 on top. The big guy wins, and that's on the bottom. So I end up with negative m over n squared, so the negative stays there. Where the negative goes doesn't really matter if you want it in front of the whole thing or on top. Usually we don't like it on the bottom. Sometimes things get a little more complicated. So for example, you look to common factor. So on the bottom, I will factor out an x or a negative x, or a negative 2x actually, and I can be left with then 1 minus 5x. And when you common factor, you look to cancel out after factoring. So I have an x here and an x here, and that just becomes 3/2 over this, or 3 over negative 2 times this. What's going to end up happening, and the main part of this is now we're going to factor fully. So if you have things like a simple trinomial, you're going to factor this top trinomial I should say, into x minus 6, x plus 1. I want two numbers that multiply to negative 6 and add to negative 5, and there they are. And on the bottom, this is two terms with a negative between. This is your old friend, the DOS. And that's x plus 6, x minus 6. And then you look up and down and you say, does anything cancel out? And yes, they do. They cancel out here. And I'm not going to scratch them out yet because I want to go and talk about restrictions also. So that's that. And then when you cancel the minus 6 out, you end up with this. And that's simplest term. But before we cancel out, you need to look at this version, the fully factored version of your equation here, and figure out what is on the bottom. Because if you remember, we talked about fractions. We don't like to have zeros on the bottom. Okay? And if that's the case, if you have zeros on the bottom, so sorry, another technical issue. Sorry, no zeros on the bottom. And we talked about that with yesterday's note, talking about friends and whatever. But if you didn't see yesterday's note video, 0 over 5, that's great. That means I have 0 of something and I divide it into 5 pieces, and I still have 0. So I'm looking around right now. I have 0 tomatoes, 5 fingers. How much tomatoes on each finger? 0. Bizarre question, I know. This guy makes no sense. This is 5 tomatoes and 0 fingers. And then I say, how many tomatoes go on each finger? And the answer is, I don't know what you're talking about. Okay? So you cannot have a 0 on the bottom. And if that's the case, and this happened yesterday, before we cancel out, we need to state our restrictions. So x plus 6 can't be 0. So that means x cannot be negative 6. Because if this was negative 6, then I'd have negative 6 plus 6, which is 0. And then I'd have something 0 times something, or the whole thing would be 0 on the bottom. Denominator cannot be 0. So I state my restrictions and I move on. But don't forget to do this before you cancel out. You can't state restrictions here, okay? Because if you go all the way back to here, if I went to the simplified version here and I said x cannot be negative 6, okay, and that was my only restriction, that's not saying that 6 won't work. Which means if I threw 6 in here, by only having this restriction, it's stating that a value of 6 would be fine, but it's not fine because 6 squared is 36, and 36 subtract 36 is 0. So state your restrictions here. Okay, just have a nice little pile there. So you just factor and then move on and cancel out and state restrictions. So you always look to common factors. So if I'm looking here, I look to common factor first. So I'm left with this. And then on the bottom, I want two numbers that multiply to, that's a negative, I guess. And is it a negative? Let's make that a negative. And that's a -3. So I look at that, and this is a difference of squares. So I keep going. And before I start crossing out, I need to state my restrictions. And that's x minus 3 all squared, or x minus 3 times x minus 3. And then I look here and I say that this is telling me that x cannot be 3. That's telling me the same thing, so I'm fine. And then scratch that out, and that's my simplified version. Okay, so nothing new, combining a couple things we've done the last few days, and that's that. One thing I would definitely suggest is when you have something like this, 14 minus 2x, is that you rewrite it as minus 2x plus 14. So you do this, and then you do this, and then otherwise you probably will not notice that things are equal. Okay, so if I common factor on the bottom, I'm going to take out a 2, and I'm left with x minus 7, and then I can cancel out and end up with 1 over -2. Okay, if the whole top or the whole bottom cancels out, then you replace it with 1. And if it's on the bottom, you just write it without the denominator. Okay, for example, if I had 3 over 1, I just write that as 3. But if I had everything cross out over 3, I'm going to make it 1/3. And that's what happens here. Everything cross out over 2, that's negative. Okay, so be careful. If I had common factored this one right off the bat, I might have common factored a 2 out, and then I'm left with this. Okay, and that doesn't look like it's the same as this, and it's not the same as this, so I cannot cross them out. You can't cross this out with this. They're not the same thing. So be careful. Write things in order properly. And that's about it. This one here, how are you going to factor this guy? Decomposition or Australian method. You're on your own for that one. And you might common factor and then use decomposition Australian method and cross out, and that's it. Okay, so lots of the same stuff. If you don't like decomposition Australian method, you can use the quadratic formula, but then you might have a bit of a hard time putting your brackets in. Okay, so for example, if you just do this one like this, you end up like this, and then this is good because the restriction will be a fraction. So I just want to do one like this. So I factor both of the numerator and denominator, and then before I cross out these x plus 5s, I'm going to tell you that x cannot be -5. And from here, I can do this in one step. It's going to be negative, change your sign, -4 over 3. Okay, that's your restriction. And just keep a nice pile like that, and then circle it a lot better than I just did. Okay, that's it. That's stating restrictions and simplifying rational expressions. See you later.